Dear students, how are you? Hopefully you are well. This is Amit Saha, lecturer, Department of Mathematics, Milestone College. Today, our discussion topic is circle. And this circle is very important for our everyday life because we need to know the history behind the circle. The circle is the word come from a Greek word named kirkos, and the meaning of it is hoop or ring. Human concept is natural to the circle, and three Greek philosophers named Euclid, Aristotle and Plato, they have invented the process of the circle, and Ryan purpose in 1700 find the process to find out the formula of the circle. The circle is very important to our everyday life. At the case of in our geometry part, especially the coordinate geometry, then there is some calculus part, and there is also our web designer or computer designing part. All the parts are very important, the circle concept. Similarly, it's very important to our everyday or the modern communication, because at the ancient time a wheel is invented at the ancient time, and later on it actually makes revolutionary, and we have seen this, the communication part. Thank you. Okay, dear students, so let's have a look what actually in our content. Our today's content is theorem 25, 26 and 27, and first theorem is 25, and the statement of the theorem says the tangent drawn at any point of a circle is perpendicular to the radius through the point of contact of the tangent. So here there is given something. What actually given? We have to find out the statement. There is given the tangent drawn, it is already drawn at any point of a circle. So if we are thinking that this is a circle and the point is P, then we can say then it should be perpendicular to the radius. If our radius is OP, then we can say this OP is the radius which must be perpendicular, and that means actually it should be create a 90-degree angle. So it is the point of contact. The point of contact means a point where we are drawing a tangent as well as the radius. So here just we are going for our special nomination. Let us assume that our tangent be PT. So let us assume that our PT is the tangent and O be the circle. So we can say PT is a tangent having the center O is in the circle of APQ or APC. Okay, so this is the tangent is given. O is the center of the circle, and here the radius is OP. OP is the radius, and we need to prove that what the point of a circle is perpendicular to the radius, that is, the tangent is perpendicular to the radius. So we have to prove that, or it's required to prove that it's required to prove that our tangent OP is perpendicular to our tangent PD. So OP is our radius which is perpendicular to our tangent. Now we are going for the construction part. Our construction part can be, the construction is, let us assume that a point, any point like Q is on the tangent PT, where this Q should be added with O. So our construction part can be join OQ, where the Q point actually on the tangent PT, where this point not on the circle, because on the circle point is only one, that is P, which is known as the point of contact. Now we move on to our proof part. So here now we are thinking for the proof part. in this part, first of all, we need to think about same thing, that is, what is our tangent? Our tangent is phi t. So phi t be our tangent having center O of a circle, where OP is the radius. Again, OP is the radius. In this part, we can say this P point is only one point which is actually on the circle. So P is a point which is on the circle. Okay, and every Q on the tangent, for every point of Q on the tangent must have to lie outside the circle. That means if we are taking any point on PT, all should be lie outside the circle. Only one point Q, which is only one point P, which actually lie on the what? Tangent. And also it is a point of contact because it is also a part of the circle. Okay, so only P is the point which is on the circle. So all point of Q is lie outside the circle. So we can say what will be the distance from OQ and OP. The distance of OQ is must have to be greater than the distance OP. So if we are taking here our Q, then this distance must be greater than the OP. If we are taking here, or even here and here, any point, if we are thinking that this is our Q point, all Q point must have to be greater, or for all Q point, all the distance of OQ must be greater than the OP. Why? Because P is the point where it is lie on the tangent as well as our circle. That's why OP should be less than the OQ. So OP is the shortest distance. OP is the shortest distance. Since OP is the shortest distance, then we can say that this is the line, this is the line, means OP is the line which must be actually creates an angle of 90 degree with PT. If it creates an angle of 90 degree, then we can say this is nothing but the perpendicular on PT. So our PT is perpendicular on OP. That's the proof. Okay, dear students, now we are move on to theorem number 26. In this theorem, there is talking about two tangents. Two tangents are drawn. First of all, what is tangent? Tangent, if this is a circle, tangent is something which must be touches a point. Tangent is a line which must be touches a point of a circle named as the tangent. And what is the normal? Normal is something which generally cuts the circle into two parts. So this is the normal, but this is the tangents. So this is the basic concept of the tangent, where it must be touches a point of a circle. So what actually talking about? Here is given that if two tangents are drawn to the circle, from an external point, the distance from that point to the points, means this point to the points, that means A and B points of contact are equal. So here is actually, if we are thinking that O is the center having the circle ABC, and P is an external point from which if we are draw two tangent on the circle, suppose PA and PB, where P and A and B are 2 points on this circle, then these two sides are equal. According to our scheme or the theorem, we can say this. So what should be our spatial nomination of the proposition? Our proposition can be what? Let P be an external point. P be an external point from which are drawn to a circle ABC having center O. So let what P be an external point is drawn to a circle from an external point P. Okay, so two tangent is PA and PB. So we can say that PA and PB are two tangents. Okay, PA and PB are two tangents are drawn to a circle from an external point P. This is the spatial nomination or proposition, and we have to prove that, or it's required to prove that what these two sides must be equal. According to this part, that the distance from the point to these points of contact are equal. That means these two are equal. So PA is equals to PB. Okay, and let us go on for some construction. Our construction part says we have to join three things, that is OB. So join OB, OA and OP. So we have to join this. This is our construction. Now move on to our proof part. Okay, at the case of proof part, what we have been observing from the figure, we have observing that there PA, suppose PA is the tangent, PA is the tangent and OA is the radius. Okay, PA be the tangent and OA is the radius. Okay, according to our previous theorem, we can say that tangent and radius must have to be perpendicular to each other. That means we can say PA is creating with 90 degree with OA. That means PA is perpendicular to OA. So we can say that our A angle or PAO is 90 degree. So we can write, or our assumption should be PAO equal 90 degree. Similarly, what we can write that PBO is also 90 degree. Why? Because PB is the tangent and BO is the radius, and we know the radius and tangent must have to be create an angle of 90 degree. Now if these two are 90 degree, then we can say POA and POB actually are two right angle triangle. So from two right angle triangle, we can say from right angle triangle PAO and angle PBO, from this two right angle triangle we can say this part is equals to this part. Why? Because these two are the radius. Since these two are radius, then we can say OB equals to OA because of the same radius of same circle. That will be the good radius of the same circle. Okay, radius of same circle. And we can write also PO equals PO because these are the same side. PO equal PO, these are the same side of these two triangle. Same side. Okay. So since this is the angle are already equal and this side equals to this side and this side equal to this side, then we can say this two triangle is nothing but the congruent. So we can say that PAO and PBO are two triangles are congruent. Since these two triangles are congruent, then we can say every side must be equal to every side, every angle must be equal to every angle. On the sense, we can say that obviously this side is equals to this side. That is, we can say PA is equals to PB, hence proved. Clear? Okay, dear students, that's our last theorem for this lecture, and this theorem number 27, and it is talking about two circles touches each other externally. This is touch, the two circles actually touch each other externally. The point of contact of the tangent and the centers are collinear. So here they're talking about there is two circles, they actually touches each other at externally, that means at the external point O. So if there touches each other at externally, then the center and this point must be collinear according to our theorem statement. First of all, what does it means that is collinear? So I was talking about concyclic. Concyclic, that means it was same. Con means same and cyclic, that means circle. So if there is something like concyclic, that means if there is some points and all points must on the circle. But since here is talking about collinear, that means actually if there is straight line, that is linear, and since here is co, that means if there is some points, all points must have to be lie on the line. That is the basic concept of the collinear and the concyclic part. However, let's get our main part, that is the theorem. In this theorem, there is talking about two circles touches each other externally. The points of contact of the tangent and the centers are collinear. So our spatial nomination should be what? Spatial nomination can be, let a circle having centers A and another circle having center B. So we can think that there is two circles having center A and B. Two circles having center A and B touches at the external point O. Touches externally at point O externally. Okay. And we have to prove that this two center and this point must be collinear, or that means they actually create 180 degree or it creates a straight line angle. So we have to prove that, or it's required to prove that, as you wish you may write. So it's required to prove that A, O and B are collinear. These are collinear. So our construction part is there. Some construction part is, since there actually touches externally, so there must be a tangent. Let the tangent is POQ. That is our construction part. Our construction part is, let A or POQ is the tangent, since their touches each other externally, and we have to join two points, that is OA and OB. Join OA and join POB. This must be joined. These are construction part. Now our proof part. At the case of proof part, we can write what? At the case of proof part, we can write from here that since OA is the radius and POQ is the tangent, then our AO must be perpendicular to POQ. That means this angle is 90 degree, isn't it? So if AO is perpendicular POQ, similarly we can say BO will be must be the perpendicular to POQ. That means actually angle POA is equals to 90 degree, angle POB is equals to 90 degree. So if we are giving this 1 and 2 number and add these two, then we'll get what? POA plus POB is equals to 180 degree, and POA and POB, that means actually AOB angle. So AOB angle is 180 degree. That means AOB is our straight angle. That means AOB is our straight angle. Since this is a straight angle, that then we can say AOB is none but the AOB is nothing but the collinear. Hence proved. I think you can understand the concept why we are going for this theorem. Dear students, when you are thinking or listening or attending these types of video class, must have to keep note, must have to write, then it will be very helpful for your betterment. Thank you.